Well, in this new chapter, we're going to be solving systems of linear equations. And in this section, we will study first systems of linear equations in two variables. So this will be two equations with two unknowns. And let's start off with making sure we know what a solution is. Is the ordered pair 12, 10 a solution to the following system of two linear equations? Now this is an ordered pair, so that means x is 12 and y is 10. So in order to be a solution, this ordered pair has to satisfy both of these equations. So let's see, we've got 5. Is it true that 5 times 12 minus 4 times 10 is equal to 20? I'll put a question mark there. Well, 5 times 12 is 60. 60 minus 40 is indeed 20, so that's good, but we're not done. We have to check in the second equation as well. So this would be 3 times y is a 10. Is it true that 3 times 10 is equal to 2 times 12 minus 1? I just substituted x equals 12 and y equals 10. 30 equals 24 minus 1. 23. Absolutely not. That was a question mark on that equal. That one failed. So the answer to the question is no. Any ordered pair that is a solution has to work in both equations. It has to satisfy both equations. Well, let's take a look at the ordered pair 8, 5. My guess is it will. Since I did one example that didn't, my guess is this one is going to. So let's make sure that, and remember 8 is x, 5 is the y. So 5x would be 5 times 8 minus 4 times y is a 5 equals 20. Is that true? 40 minus 20 equals 20. That's true. Now we have to check the second one. Y is a 5. So 3 times 5, is that equal to, I should have put a question mark since we were checking both of these, is 3 times 5 equal to 2 times 8 minus 1. 2 times 8 minus 1. 15 equals 16 minus 1 is 15. It works. So this ordered pair, yes. This ordered pair is a solution to this system of two equations. This ordered pair, 12, 10, is not. All right, well, let's look at a fact about a system of two linear equations in two variables. How many solutions can it, well, let's go back to this example. We did not prove it, but this ordered pair is the only solution to this system of equations. We didn't show that, but it is. So, how many solutions can a system of two linear equations in two variables have? Well, one of the options is 1. I just explained that one. But it's possible there could be no solutions. And then there's only one other possibility, and it's not 2 solutions, it's not 3 solutions, it's infinitely many solutions. Infinitely many solutions. And what does it mean? What can you tell me about the two lines, the system of two linear equations, if the two lines are intersecting at one point? How many solutions would there be if the two lines intersect at one point? Well, that would be similar to this case. It's 1. The number of solutions is 1. And in fact, the one solution will be the one single point where they intersect. That is the only point that would be on both of those lines. So drawing a picture, we could have something like that. Put some arrows on the lines, and that's very small, but that one single point would be the intersection. That would be the solution to the system of the two equations. Okay, two parallel lines. How many solutions? Well, how many points are on both of the lines? You have to be a solution, you've got to be on both of the lines. Clearly that's 0. If you have a line like that and you have a parallel line like that, how many points? Is there a point that's on both of those lines? Absolutely not. So there's 0 solutions. And lastly, is the case where they're identical lines. Sometimes I say coincident. They're the same line. So to draw the picture, this is difficult to draw because you just have to draw one line and then say, maybe that's line number 1, but in fact, it's also line number 2. They are the same line. So what points are on both of those lines? Every point on the line. Remember, they're the same line. This would be infinitely many solutions. That's the 3, geometrically speaking or graphically speaking, these are the 3 possibilities. 2 lines that intersect at one point, that means 1 solution. 2 parallel lines, there's no point on both of the lines, so there's 0 solutions. And then the case where the 2 lines are identical or coincident, every single point on that line is on both lines, every one of them. So we have infinitely many solutions. Okay, let's look at a recipe on how to solve a system of 2 equations by substitution. This means we're not going to have to graph at all. We're just going to use these 2 linear equations to solve. So what you do is you solve either equation for either variable. Choose your favorite one. I think I'm going to solve equation 2, the second one, for y. And that would be as simple as saying y equals 2x minus 9. All I did is subtract 9 from both sides. So we've done step number 1. Now we're going to substitute the expression from 1 into the other equation. Notice y is equal to this that I have in the box, 2x minus 9. I'm going to plug that in place for y in the first equation. And let's write that down. So now I'm really writing down equation number 1 with this substitution. It would be x plus 3 times y, but y is this, 2x minus 9, equals 8. This is our new equation number 1, and notice it only has one variable in it, only x, and that's easy to solve for. And that's what the next step is. Solve this equation for x. And I'm going to distribute here, so I'm going to get x plus 6x minus 27 equals 8. All I did is distribute the 3 through the parentheses. That's all I did. And now let's solve this. So we have 7x's there. 7x minus 27 equals 8. Let's add 27 to both sides, giving it 35 on the right-hand side. 7x equals 35. Divide both sides by 7, and we get x equal 5. That's half of our solution. We found x, now we need to find y. So we're going to back substitute to find the other variable y. So we can plug x equals 5 into either one of these 2 original equations, and I suggest you do both just to make sure. If for some reason we made an arithmetic mistake here, when we plug into equation 1, we'll get one value of y, and plug x equal 5 into the second one, we would get a different value of y. So let's make sure we didn't make any arithmetic mistakes. So equation number 1 turns into 5 plus 3y equals 8, and all I did was replace the x with the 5. And that would give us 5. If I subtract 5 from both sides, 3y equals 3. And that means that y is equal to 1. So I believe that's my correct answer for y, but I'm going to double check it, make sure we didn't make any arithmetic mistakes by plugging in x equal 5 into equation number 2 as well. Y plus 9 equals, if x is 5, 2 times x would be 10. And what does that mean? Well, if we subtract 9 from both sides, we get y equals 1. So in fact, that was correct. So the solution would be, and actually we just did this step as well, we just checked the answer. The solution is x equals 5, y equals 1. So that's the ordered pair. And graphically speaking, what that means is if I graphed both of these lines in the xy plane, both of these two lines, the one point where they intersect with each other would be the point 5, 1.